Welcome everyone. My name is Adeoye Emmanuel, an AWS Solutions Architect. Today, I'm exploring a production-ready Amazon Elastic Kubernetes Service architecture that demonstrates how to run containerized applications at scale on AWS. This is the exact setup used by companies worldwide to deploy microservices, web applications, and APIs with high availability and automatic scaling.
Welcome back. Let me walk you through the AWS architecture I designed for this solution. The first one is Application Load Balancer, the entry point for user traffic. The next one is Amazon Elastic Kubernetes Service Cluster. This manages Kubernetes control plane. At the heart of our architecture is Amazon Elastic Kubernetes Service. It manages Kubernetes for you. You don't have to handle the setup, scaling, or control plane yourself. AKS provides the Kubernetes control plane that orchestrates our container deployment, scaling, and management. This is the orchestration brain that makes sure your application runs reliably. Finally, the critical security layer, IAM roles and policies. IAM control permissions across all AWS services in our architecture. Now let's trace a complete user request through our system. The user sends HTTP request to the application load balancer. Application load balancer request to LT host in Elastic Kubernetes Service cluster. The AKS ensure POCs are distributed across worker nodes. Now worker nodes pull all container images from ECR. Application put processes request and return response. Now IAM policies authenticate every cross-service interaction. These steps give a high available, scalable, and secure application platform that automatically handle traffic spikes and failures. Now let's talk about its business benefits. The first one is cost optimization, that is pay only for EC2 instances and application load balancer usage. The second one is auto scaling, prevent over provision. The third one is manage AKS, reduces operational overhead. As architects, we face two realities. Number one, time to value matters. That is, clients need working solution fast. The second one is complexity hides insights. Too many steps obscure architecture principle. So I have created what I call the architect's shortcuts. Deploying Elastic Kubernetes Service with just 3 files and 5 commands. This is not cutting corners. It is strategic simplification to showcase the core value: Kubernetes orchestration on AWS. Welcome back. As a solution architect, I understand that cloud security is non-negotiable. In production, we never expose sensitive information, but today, I am making a deliberate exception for this education demonstration. I will be showing you complete architectural details, including information I will normally protect, because this is a controlled demo environment that I will destroy immediately afterward. This transparency allows me to demonstrate my full range of skills from design to implementation. to responsible cleanup. It is important you understand this openness is for education, not my standard procedure. I believe code should tell a story, not just how something works, but why it was built this way. Let me walk you through each file in this elastic Kubernetes service deployment and explain the architectural decisions behind them. This is the Python code of the project, and I want to show that this is not just a flat app. This is a communication tool that demonstrates architectural principle through its endpoints. Now let me explain some part of this code. Now look at it. This forward slash, this is the architecture statement. It returns JSON file showing our deployment principles. Now let me look for slash highlights. Now look at it. So this is the production readiness. It shows we understand monitoring needs. Let me look for the architect. Now look at this architect, this intentional design. It explains why we make certain choices. Let me look for this is the Kubernetes integration. It proves for orchestration. The application doesn't just serve requests, it explains itself. This is crucial for maintainability and knowledge transfer. Now let's look at the Docker file. So every line in this Docker file is an architectural decision. So from Python 3.9, this is the security and size trade-off. Now the user approval. Let me look for it. User. Now this user app user. This is the security first approach. This user app user is the security first approach. Now let me find health check. The health checks. Okay, this health check is the production readiness for Kubernetes. Let me look for environment variable. Okay, this is the environment variable. This is the configurable, not hard coded. A container should be secure, efficient, and self-documenting. This Docker files shows we understand all three. Now let's look for requirements tests. These are the dependency management. So here we have flags 2.30. Now, minimalism is an architectural choice. Our dependency means security, that's fewer attack surfaces, maintainability, so it is easy to update, and clarity, no hidden complexity. So only include what you need. Every dependency is a future maintenance cost. Okay, now let's look for orchestration blueprints. This is our orchestration blueprint. Now, this is where architecture meets operations. Now, you see this namespace. The namespace strategy is isolation and organization. It's for isolation and organization. Now, there's another thing we call resource limits. See, the resource limits is about performance and cost control. So let's look for the proofs too. Proofs. And you see, this proofs is self-handling architecture. Next one, look for running updates. You see, this running update is the zero downtime deployment. The service, for service types. This service type, this service type is for load balancing strategy. So Kubernetes are not just configuration, they are infrastructure as architecture. Now let's go to deploy, which is our deployment pipeline. You see, automation is architecture. This script shows order of operation, logical deployment flow. It also gives error handling, the verification, clean output, professional communication. So manual deployment is a risk. Automated, documented deployment is architecture. Now let's go to cleanup. Is it cleanup? This cleanup architecture is not just about building, it's about responsible management. The cost awareness. So it means that you clean up unused resources. So if you can't clean it up easily, you should not deploy it. This is not just deployment code. It is an architectural story told through files. This, I will create our entire infrastructure with one command. So, EKS Okay, now the region. prefer using non-vaginal. Yeah, that's US East. The node group name, I call it workers. So the node type, that's the instances type. Let me use data small. The reason why I'm using this small data small is cost effective for demo. So the nodes SA3. Oh, you can see where I made mistake. It's not node. Use double. Okay. Perfect. Our elastic Kubernetes service cluster is now active. Let me show you what just happened. Let me show the cluster info. Now see these 3 instances. AWS just provisioned them as our Kubernetes work nodes. Notice they are in ready status. See, they are in ready status. That means our cluster is healthy. Let's explain the architecture. Here is the magic. This shows our Kubernetes control plane managed by AWS and our worker nodes we just created. So AWS handle the complex control plane. We focus on our application. Now let's see what is running. Good. Even an empty EKS cluster has system posts running. These are core DNS for service discovery, kube proxy for networking, and AWS CIN for pod networking. This is production grade Kubernetes out of the box. So simplicity is strength. Notice my command was simple. From the beginning, my command was simple. Why? Because as an architect, I know when to use defaults. AWS has smart defaults for VPC, security groups, and networking. I am leveraging AWS expertise, not reinventing it. Now, the cost consciousness. I use T3 small nodes are perfect for demos, about $0.02 per hour. We balance performance with cost from day one. This cluster costs less than a cup of coffee per day. Production ready. Even though this is a demo, it is production architecture. Auto-healing nodes, secure networking. This is not toy Kubernetes. It is enterprise grade, just sized for demonstration. Now that our EKS cluster is ready, let's focus on the container lifecycle, the art of modern application. Watch how I handle this with strategic simplicity. Now, Docker, build, yes. Build architect, demo, strategic. Perfect timing for real world moments. We have just hit a common issue that every architecture encounters. Watch how I will handle this. Let me check if the Docker is running. System. Oh, I've forgotten. I'm using Mac. So it's for okay. Okay. Okay, this happened because Docker run as a background service. That's demo, and my build command need to communicate with it. Let's check and fix this. Okay, let me open Docker. I have Docker here. Okay, I've opened Docker. While it starts, let me share an architect insights. Container tools are just
It's 4 o'clock.
infrastructure, just like AWS services need to be running. Local Docker needs to be running. This is why in CI/CD pipelines, we use managed build agents. They always have Docker ready. Here is Docker desktop starting up. Good, let's verify Docker version. We'll see both client and server version. The server part is the demo, and Docker info show our configuration. Now let's continue with the build. Let me remember okay, it's my code. And now our build works. watch the layer download and build. Each step you see represents a layer in our doc image. Notice the size. Our Python Slim image is small. That is intentional. So in cloud architecture, size matters. Build complete. Now we have our container image ready. That's a great one. Now let's proceed to ECR repository creation. Okay, that's AWS ECR. Great. Repository. Now repository name. Let me call it architect demo. Let's add region. Good. Now, where do we store this container? In Amazon ECR. AWS Manage Container Registry. Notice something important here. I'm using AWS CLI, not the console. Why? Because as an architect, we need to document our infrastructure. This command could be in a script, in a Terraform, in CloudFormation. It's reputable, fashionable infrastructure. I'm not specifying advanced settings here. Why? Because for a demo, defaults work perfectly. In production, we will add tag immutability, scan on push, lifecycle policies. But today, we are demonstrating core workflow, not heavy security feature. Now for the pivotal point, where our code meets infrastructure. This is where architecture becomes reality. Watch closely because this next 30 seconds will transform a container image into a scalable production-ready service on AWS. Now, I have 3 files already. Our Elastic Kubernetes Service cluster is running and waiting. So let me show you the deployment magic that connects all the 3. So now let me update the image in manifest. No, this set command is not just a text replacement, it's an infrastructure configuration. I understand that manifest should be parameterized. We are using our actual AWS account, ECR. Okay, you see, this latest tag gives us deployment flexibility. Think of this as telling Kubernetes, hey, the container you need is at this specific address in Amazon Container Registry. It is like giving GPS coordinates to a delivery driver. Let's continue. Kubernetes. So this single command Kubernetes apply is where the orchestration engine starts. It's telling Kubernetes, take this blueprint and make it real. But let me break down what's actually happening. What I call it kubectl does. It read our YAML file, contact the AKS control plane API, says create these resources. But here, the architect insight. Kubernetes does not just obey it. It validates the configuration, plans the deployment, coordinates across nodes, manages the rollouts. So watch it happen. Let's go with still get all. We got an error. You may only specify a single resource type. This is not a mistake, it's a teaching moment. In re-architecture work, errors are data, not failures. Let me showcase you why this happened and how a professional handles it. Kubernetes is telling us that wash needs us to be specific. This is actually good design. When washing resources, Kubernetes wants clarity. Let me demonstrate the architect's approach to troubleshoot and observation. Wow, interesting. We are hitting a Kubernetes version specific behavior. Some version of Kubernetes don't allow wash with multiple resource types. Now, you know what is interesting? During this deployment, I hit a classic learning moment. First, when I tried to wash everything deploy at once, the tool said, hey, I can only wash one thing at a time. Then when I asked for 3 copies of our app, the system said I can only fit 2 comfortably on this demo setup. Here is what this taught me. Tools have limits. Sometimes you need to focus on what matters most. Clouds have budgets. Real architecture works with real constraints. Perfect is not the goal. The goal is working solutions. Now let's talk about this, our deployment. As you can see, our deployment is fully operational. We have 2 healthy pods, both running and ready. 2 pods ready, all container running perfectly, 0 restart, stable with no crashes, 19 minutes uptime. That's proof reliability. Mission accomplished. Our containerized application is successfully deploy on Amazon Elastic Kubernetes Service. Comes the magic moment, verification. This is where we prove our architecture actually works. Watch closely as I show you not just that it is running, but how it is running and what that tells us about our solution. As architects, we don't just deploy and hope. We validate, analyze, and understand what we have built. Let me show you what I mean. Let me start with yes. Yes. Service. Now what I did here, as a solution architect, I'm not just running commands. I'm explaining why I'm using specific tools. Let me get our load balancer URL. So you notice I'm using kubectl, so standard Kubernetes command. This is actually standard Kubernetes command. Now the following one, I use this specify our namespace. So the following one is architect service. This architect service is our specific service name. This is our service name, and this is the architect trick, extracting only what we need. So the JSON path query, let's run it. Perfect. We have our load balancer DNS. We have it now. Working towards. We have all the posts running, all services LD. Now let's prove our entire architecture is accessible to the outside world. So as you can see it here, this is my DNS URL. So let me test the architecture. Copy our DNS URL. Our application is live and responding through AWS Load Balancer. Let me show you what this means and why it matters. Look at this application architect EKS demo. This confirms our containerized application identity is correct. These architect principles. These are the design principles I followed. Simplicity, using managed AWS services, cost awareness, and building for scalability from day one. Now, this environment shows that I deployed this with production configuration, not demo defaults. Now look at the host name. This host name is specific Kubernetes pod served our request. The load balancer distributes traffic across multiple pods for high availability. This operational output is our application report itself as fully operational, health check and passing. This is the real-time response. The application is alive and processing request. Now look at this version. This means a proper versioning for deployment, tracking and rollback capability. This is a successful response, proves our entire AWS architecture is working. ACR for containers, EKS for orchestration, and ELB for load balancing. I have demonstrated I can design, deploy, and validate production-ready cloud solutions on AWS. The application is live, scalable, and delivery value. Mission accomplished.